Hello, hello, hello. Your video today is on systems of equations, being able to solve by substitution. You learned how to solve by graphing. So this is another method, and it's actually really exciting. I really like doing this stuff. It looks cool. So here we go. Before we do anything though, we need to take a step and talk about what substitution is. And so that is when you solve one of the equations for a variable and then you put in that expression in the place of the variable for the other equation. Probably doesn't make a whole lot of sense to you right now using those words, but once we start practicing it and I'll use the language of the word substitution, it'll make way more sense to you. If you think of like a substitute teacher, what do? They sub in for me as your teacher. They teach all the same stuff. It's just it doesn't look exactly like me. And so that's kind of along those lines. So let's get started. First one, we have these two equations, y equals 3x and x plus y equals negative 32. So because we already know what y equals, we solved for one of the equations. Well, we didn't, it was given to us. We can just take and substitute in that expression for what we know. In other words, it's the same thing, you're just filling the place a little bit differently. So here we have a y, here we have a y. So what you're going to do is take that expression, what y is equal, it is the same thing as 3x. You're going to put it in the same spot for y. You're substituting it in. So it's the same thing, it just looks different. And so you will be left with x plus 3x equals negative 32. The reason we have to substitute is because we have two equations, and one of them, they both have two variables, and you can't solve for something that has two variables. You have to get it down to just one variable in order to solve it. So here we solve this one. We have 4x equals negative 32. We divide by 4 on both sides, and x equals negative 8. Then, next step that you have, after you solve for x, you have to solve for y too. You can't leave that out. And so you go back in, and it doesn't really matter which equation. I typically pick the easier one. So I'm going to pick this one to substitute it in. So y equals 3 times my x, which is negative 8. So y equals negative 24. And what that means is that your answer then in xy form, coordinate points, is negative 8, negative 24. And that means that is the point, if you were to graph these, that's the point where they cross, where they intersect. And so that is how you solve. Here's another example for you. This one's just a tad bit different because we don't have something that just says y equals blah, blah, blah. We have to find it ourselves. It doesn't really matter which equation you choose to solve for y. I typically just go for the easier one, but you can do anything. So I'm going to solve for the second one. In other words, I'm just moving it around. So y equals negative 3, and then I had to add 2x on both sides, and so I'm left with that. So that's my new equation. It's just written a little differently. Same thing, but just written different. Now that I have those two, I can again substitute in. My y is here, my y is here. So I'm going to take that and drag and drop it in for that spot. I'm substituting it in. So now my new equation is 3 times that expression of y, which is negative 3 plus 2x, that whole thing, plus 4x equals 14. Now I just solve. Negative 9 plus 6x plus 4x equals 14. I'm going to run out of space here. Let's make that a little smaller. 23 divided by 10. X equals 2.3. And then we have to substitute it in. And again, it doesn't really matter which equation. I typically go to the opposite one just because it makes it a little bit easier. So y equals negative 3 plus 2x. So y equals negative 3 plus 2 times 2.3. Ran out of space there a little bit. But you know what I wrote, so that's okay. Negative 3 plus 4.6 equals y. So y equals 1.6. That means my final answer then as a coordinate point would be 2.3, 1.6. Right. There are some special cases that we need to talk about, just like when you were graphing equations and there are special situations. The same thing is true here. So the first one, infinitely many solutions. That would be the answer if when you're solving, you end up having something like 14 equals 14. And you can't solve it any further because it all ends up being the same. They're equal. That's infinitely many solutions. That's your example there. For no solution, your example would be you're solving your equation and you end up with the like negative 11 equals negative 13. That's an untrue statement, obviously, so there is no solution there. So those are the two situations that you need to be aware of as you are solving these, because they can happen sometimes, but not too many times. All right, it is your turn to solve these three problems. Go ahead and make sure you're showing all of your work. Some are a little bit easier than others, but go ahead and do those, and then check in with me when you're done for your answers. Okay, here are your answers to those three questions. Take a look at number 2. You could have not written it as a mixed number, so you could have 7.3 repeating and then negative 4.7 repeating. Either of those answers are fine. It's just something to be aware of. If you have any questions on these or how to do this, make sure you write those down on your notes page and then bring those to class so we can talk about them. Thanks for watching. Have a great day.